All right, hi guys. You know, sometimes in science we describe things according to properties. For instance, their color, or an object's shape, or an object's texture, maybe their size. For instance, a property of me is I'm extremely beautiful and handsome. Okay, maybe not. But let's say I have here two sheets of paper, and they're exactly the same. They were from the same manufacturer. If I put them together, they're the exact same size. There's no difference in the properties between them. They weigh the same, they're the same size. But I'm going to take one of these pieces of paper and I'm going to crumble it as hard as I can. And I am going to make it into a tight ball. Now, if I were to ask you which one weighs more, they're exactly the same. All I did was change the shape of one of the pieces of paper. And if you think about it, if you weighed 50 pounds and you put your hands in the air, you would still weigh 50 pounds. So nothing changed there. If you're jumping in a pool of water and you turn your body into a really tight ball, a cannonball, you put all your weight into a small space, you still weigh 50 pounds. The weight didn't change. You just changed the shape. Now, if I drop these two pieces of paper from the same height at the same time, which one is going to hit the table first? I think you know, but let's give it a try anyway. See if your prediction came right. Three, two, one, there. And we saw that the one that was a tight ball landed first. And the reason for this can be explained with air resistance. You see, the tight ball only has a small area in contact with the air. And it's also more aerodynamic, so the air can go around it better. And that's what allowed it to drop real fast. Now, our sheet of paper, it's flat. It has to move all that air out of the way to get down to the table. That's why it took longer. You can't see the air resistance, but that force, it has to move that air out of the way so it can fall to the ground due to gravity.